So thank you very much, Masood, for the invitation. Thanks everybody for the interest in the topic and for being here. Just let me see. Okay, now you can see my slide, I think.
Mhm.
It's actually a very well-chosen date today because for this talk because it's Brain Awareness Week. Um, as you see above here, and it's also Sleep Awareness Month. And my talk will be about neurophysiological aspects of sleep perception in insomnia. Um, and first, a financial disclosure, we were supported by the German Research Foundation grants. Um, and of course, the talk is not really part of the brain awareness and sleep awareness weeks and months. So the talk outline will be first generally a few words about insomnia. Since it's ENIGMA-Sleep group, I have some imaging findings for you. I will also look for the enigma of sleep perception, a few general ideas, and then I will show different studies that we have performed and conclusions. So about insomnia, very shortly, insomnia is, of course, defined by severe subjective sleep loss and daytime impairment. So that is important. It is completely based on subjective experience, subjective sleep complaints, and subjective complaints about daytime impairment. And these are obtained usually using retrospective questions or questionnaires, at least over several weeks, covering several weeks. But it's only this subjective complaint which is important, and polysomnography is not indicated for diagnosing insomnia, uh, only possibly to exclude other causes of fatigue and daytime impairment. So, of course, what motivates our research is the high burden of disease. Every practitioner in the field will see um, these patients, these people coming to them and saying, "If I could, doctor, if I could only sleep well again." My life would be much better. So this is both in the general public and in clinical populations as well. So it has in the last years become more and more has gotten more and more attention. The fact that it's very important to also monitor sleep quality in the clinical setting. Um, Even in intensive care wards, but of course also in the psychiatry, if you want to do psychotherapy with the patients, it's very important that the sleep quality is sufficient. Now about the some imaging findings. I also say non-finding because I think there's not we did not yet find the insomnia center in the brain, and all different structures of the brain that have been implicated with insomnia um, have not consistently been found. But um, Julia Aquino, visiting our group, has done a review about insomnia about imaging that was cross-molded, so it's PET, it's SPECT, it's fMRI, MRI, and connectivity, structural and functional connectivity. And we just counted which areas of the brain were most often implicated And this is the ACC, thalamus, insula, precuneus, PCC, and middle frontal gyrus. We ourselves in studies found first in a very small study a smaller hippocampal volume in insomnia, but then Kai Spiegelhalter um, could not replicate this in our group. And we also did studies on spectral power fluctuations very close, very shortly. This is, everybody knows this. This is alpha band EEG in the awake state, and it waxes and wanes this amplitude. And a while ago, it was a research question. Okay, what happens in the brain when the alpha rhythm increases and decreases? And at the time, Goldman et al. Already published their seminal paper here showing occipital negative correlation with alpha. So if alpha amplitude is up, metabolism in the occipital cortex goes down. And they also showed a very prominent positive correlation here in the thalamus that was not yet known. And we're just analyzing our data when this paper came out. And as a short anecdote, maybe I analyzed our data using the typical hemodynamic response function, HRF, and I only saw the occipital cortex, the negative correlation in the occipital cortex, nothing else, no thalamus. And then I sent the data to my collaborators who repeated the analysis, but somehow, obviously, it wasn't clear whether I've sent them the spectral power values themselves, as I did, or already the finished regressor to get already with hemodynamic response function. So they left away the hemodynamic response function. They didn't use it. And they say, oh, we don't see an occipital cortex. We only see the thalamus here, right? And our TR at that time was, it was also interleaved scanning, was 5.25 seconds. So really huge lag between two measurement and between two volumes, and this indicated, of course, that somehow this thalamic activity preceded the occipital negative correlation. And afterwards, we replicated this finding using a different method, using deconvolution, if you want the proper way to assess this. So this is here the occipital cortex, which coincides really if 0 is the moment in which alpha increases. You see that in the same moment, of course, considering the canonical hemodynamic response function, the metabolism in this occipital cortex decreases simultaneously. But the activity in the thalamus precedes the this increase.
Bernd, sorry, can you
Sorry,
minimize the right bar, like, because we
the
cannot
white
see
bar?
the right, like, bar of, like, the presentation
Yes.
showing our like images. Yes, maybe you can
Sorry,
minimize it.
sorry. Yeah, I thought you couldn't see it. Maybe I
Yeah, you
can
can minimize it. Yeah,
reduce it. Yeah,
yeah.
yeah, like this.
Thanks.
Yeah, thank you. So, okay, this is this was just the reproduction in principle of our findings. And with theta, we also did this across the different classical spectral bands. And what was interesting was that that here the supramarginal gyrus was extracted by our cluster analysis. This was sorry, I didn't say this, it was a cluster analysis separating different time courses and separating also the regions which express these time courses. And also the ACC. But now let's come to the differences between the insomnia subject and the good sleepers. This was mainly in the thalamus and in the beta range. If you see here at 0, there's in principle a beta burst, and preceding that beta burst is activity in the thalamus, which is very similar between the groups. The insomnia group is this red one here, and if you want, in the good sleepers, the thalamus disengages following the beta burst, but not in the insomnia patients. And okay, this was a significance that we found, and which can be interpreted as a sign of this hyperarousal that has also been seen in a lot of ERP studies during waking, for example. But it most, I did show this to you because I think this legged analysis is very seldom done, too seldom done, and should be done more often. And I'm quite convinced that these legs are really there and need to be considered specifically between spontaneous EEG changes and fluctuations and what the brain does. So let's come to the enigma of sleep perception. At first, of course, you might think that, well, sleep loss is the main symptom of insomnia, right? And so we have a gold standard for measuring sleep, polysomnography. So in principle, we should really have an objective correlate of of insomnia. But it turns out this is not really the case, because the polysomnographical difference that you really see between insomnia disorder groups and good sleeper controls actually quite small. It's less than it's about 25 minutes less per night, and if you only take groups that are about 30 subjects per group, you don't even see it typically, this difference in total sleep time. You don't see it when you compare these groups. You really need larger groups to see it. And that is, of course, no comparison to the subjective complaint in insomnia, which is usually a sleep loss of hours during the night. We will come to this in more specifically later. Of course, I mean, there is a certain criticism that you can do for polysomnography. Does polysomnography correctly represent the state of the brain, really? And this, in principle, cannot be, because the brain is very complicated, consists of many different parts, and describing the state of the brain by one single sleep stage for each 30-second epochs cannot be totally right, and cannot be a full description of the state of the brain. So early on, even, for example, Alan Rechtschaffen himself did some of these studies, tested against awakening thresholds. Awakening thresholds are, like the loudness of a tone at which the subject awakens. It can also be a different stimulation method to awaken people, and you record the threshold that you need, how strong the stimulus has to be to wake people up. And awakening thresholds, sometimes also called arousal thresholds, are in principle a gold standard in sleep research of measuring sleep depth, if you want. And it was actually sleep staging was tested against awakening thresholds, so it was ensured that on average actually awakening thresholds are higher if people sleep deeper. But this awakening thresholds were, of course, never incorporated into sleep stages, into sleep staging, were never a part of sleep staging itself, because, of course, the big advantage of our polysomnographic sleep staging is that it doesn't disrupt sleep. So it neither reflects awakening thresholds, but it also was not constructed to reflect subjectivity, sleep perception. So we should not at all be surprised if we find that different people have different waking threshold in the same sleep stages, or if people perceive sleep differently in the same sleep stage. So one can say that sleep staging is a heuristically derived surrogate for whatever brain state we call sleep, and it's complicated things, of course. Stefan and Ciclari published a paper reconsidering sleep perception in insomnia from misperception to mismeasurement. But it should, I think we really all mean the same. I would say, okay, in the same sleep stage, you can have a different sleep perception or different awakening thresholds, for example. They say maybe sleep is mismeasured. But according to what I said above, I do not consider really our sleep staging a measurement of sleep in this sense, because it's a heuristically derived surrogate. So another reason why there was, as I said initially with the imaging studies, why there are so few really conclusive findings, conclusive objective findings in insomnia, can be that insomnia is a heterogeneous disorder, and this is, I think, undisputed that this is the case. But previous ways to define subgroups were not really successful. For example, in ICSD 2, International Classification of Sleep Disorder, version 2, defined several subcategories, primary and secondary, and the primary insomnia was split again into psychophysiologic, idiopathic, and paradoxical insomnia. But this separation proved not helpful and was dropped for ICSD 3. And also in DSM-5, we now have insomnia disorder, which allows comorbid diagnosis, and also is not further split into different subgroups. Of course, the Vogontas group defined insomnia with short sleep duration. So in principle, they made the polysomnography a criterion in discriminating objective short sleepers. This is the total sleep time. Objective short sleepers would be on this side, and the others, which do not show such a strong objective sleep loss, polysomnographically defined sleep loss. Now, these histograms I just prepared from our database, 558 ID patients, and you see the distribution of total sleep time is unimodal. So we see no sign of a bimodal distribution, which would indicate that it makes a lot of sense to separate these two groups. And in fact, if you cut here, this is the median, the blue line. If you could cut here somewhere close to the modus, of course, you will separate a lot of people into one or the other group just by a difference of some minutes, because here are just most people. What we also often consider is subjective wake excess, so the difference between subjective subjective wake time minus polysomnographically defined wake time within the same night of the polysomnogram. And both, I would say, it's not that these parameters are senseless, but we use them typically as continuous parameters. I think they do give us information about patients, just as the age, for example, of a patient gives us information, but it's rather continuous. So there is another approach by Tessa Blanken from Özpan Sommeren group. She published insomnia disorder subgroups derived from life history and traits of affect and personality. So there is no polysomnography in there. There's also not an insomnia severity in there, but rather aspects such as pre-sleep arousal or the reactivity of the insomnia to stressors. And this, I think we will hear more about this. This is a very promising way to define insomnia subtypes. Now, okay, I think you can also not see. This I could move as well somewhere else. Okay. Oops. Yeah, there it is. So what is really sleep perception? This is a study authored by Feige in our group, where we looked at sleep time, the sleep duration in minutes, so that's total sleep time, subjectively and objectively across good sleeper controls and insomnia patients. And you see here on the right side are the 2 nights that we typically do with every subject, and PSG1 and PSG2, and also the SFA1 and SFA2. These are the subjective assessments, in principle, a sleep diary that pertains to exactly this night. And you see here the difference, in particular between subjective and objective, and also the difference to good sleepers is not so large, actually, specifically here with the objective sleep duration. And the more, if you get over here, this is the 2 weeks of sleep diary that we do before the sleep lab visit, and you see that this difference, especially to good sleepers, is already much larger. And then the Pittsburgh Sleep Quality Index, which is retrospective, shows the largest difference to good sleepers. So I think now since we have so many different differences between good sleepers and insomnia patients, the question arises, what really is sleep perception? I think most clinicians will see this very large difference mm, between this retrospective measure here and the retrospective sleep complaint that really defines insomnia. Um, they will see this as the subjective, well, sleep duration, and the polysomnography, and we'll compare this to the polysomnography, right? So, but this difference here between polysomnography and this retrospective sleep complaint, which is, for example, also included in the Insomnia Severity Index and so on, is very hard to assess experimentally. What we have done was to compare always the same night. So we looked at sleep perception subjectively in the same night as we have in the that we have for our polysomnography night, and looked at specifically that discrepancy. But as I said, this is not the way that all the clinicians would usually look at things. So we did our first study on this discrepancy between subjective wake time in the same night of the polysomnography and the different sleep stages in order to find out what really creates or influences subjective wake time. And this was just a linear model, and then we used the AIC to eliminate terms one by the other. So this, all non-REM sleep stages went away, leaving only the polysomnographically wake time, defined wake time, which makes a lot of sense, of course, and the polysomnographically defined time in REM sleep. So this actually means that the coefficient was about 0.4, 0.5 here, which would mean that within the insomnia group, the about half of the REM sleep duration was actually experienced as subjective wake time. We also saw increased arousal index in REM sleep. There's a slight increase in non-REM sleep here as well, but very strongly in increased arousal index in REM sleep. And in addition, REM it's a known finding that REM sleep percentage is reduced in insomnia. And taking all these things together, now I have to put this somewhere else again. Taking all these things together has led to different terms, which I would just use as working titles for and names for these observations that we have seen. The term REM sleep instability, restless REM sleep, and hyperarousal, of course, in REM sleep. In principle, I would see these as an expression for this difference that we've seen. Obviously, REM sleep quality is changed. That's the central issue. REM sleep quality is changed in a way that it is experienced more, perceived more as wake than in good sleeper controls where we don't find an influence of REM sleep. on subjective wake time. The increase in arousal index was not always replicated, but even without this, so without the assumption of an overt REM sleep fragmentation, this idea of a qualitatively modified REM sleep remains. But of course, this whole analysis is quite far away from the actual sleep stages. We just compared questionnaires obtained after people awoke in the morning, of course, with the time spent in the different sleep stages. And it still could be, some kind of memory effect or so that that causes the time spent in REM to correlate with subjective wake time. It must not be really that they experience REM sleep itself as more awake. But to clarify that, we did an awakening study and this was 27 subjects per group. I will shortly explain the procedure. We had adaptation and baseline nights, and then we had awakenings, 3 awakenings from non-REM in one of the following nights, and 3 awakenings out of REM sleep in the other of the following 2 nights. And it was always after at least 5 minutes of stable REM sleep or N2 stage. And I don't know whether you can hear this noise that is repeating every 4 seconds. So this and increases in loudness, of course. And this noise was used to wake the subjects up. Subjects pressed a small micro switch strapped to their thumb to indicate that they were awake. And afterwards, somebody very quietly entered the room and asked questions. The very first question was, have you been asleep? Yes or no? When you heard the tone. Second, how sure are you about your judgment? And then there were different questions about the intensity of positive and negative emotions. Now, of course, the actual, if you want, neurophysiological marker that we targeted here was, of course, the awakening threshold. So a hypothesis was and would correspond to previous papers, very early papers by Mendelssohn, for example, et al., that in insomnia, actually, the awakening threshold is reduced, is smaller than in good sleeper controls, documenting higher arousability, if you want. And therefore, it would be also clear that the sleep might be perceived differently, right? So if you plot the arousal or awakening thresholds here over the 3 awakenings per night, this is for stage 2 sleep, you see, well, no group difference, at least no significant one, only very small, but a quite clear reduction of awakening thresholds over the course of the night. This corresponds to the literature, and it's relatively similar, although more with somehow larger variability within REM sleep. Now, next, if we analyze what did the subject say when they were awoken in stage 2 sleep and in REM sleep, well, about 20 to 25% of subjects in either groups felt that they had been awake when they had been awoken by our procedure. This also corresponds to the literature. And it's a quite similar figure for the insomnia patients here. In REM sleep, it's only a little bit smaller. And there is a significant group effect, which is caused by the fact that the good sleepers practically never say they had been awake when they were awoken from REM sleep, right? So this makes the mean difference. Um, so we found actually a difference in REM sleep and also the certainty of sleep judgment was lower in it was significant in REM sleep. It was generally lower in the insomnia patients group. And well, we can look at the emotions. There's positive emotions in general were a little bit more often mentioned in REM sleep and after the REM sleep awakenings, and negative emotions were maybe a little bit more often mentioned generally in REM sleep, but the insomnia patients more often had clearly higher and significantly higher a number of mentioning negative emotions after being awoken from REM sleep. We can also look at this over the course of the night. You see here again these three awakenings over the night, and positive emotions are on the top row, negative on the bottom row. Stage and 2 is on the left side, stage REM sleep on the right side. And you see that the only significant difference between the groups is this here at the end of the night, actually. So the mean difference in the incidence mentioning of negative emotions after being awoken from REM sleep is mostly here at the end of the night. And we took that as an indication that in principle, insomnia is like a bad dream. It's like a nightmare, a nightmare of not being able to sleep. And this has consequences. For example, we think that elements of nightmare therapy could actually be used for the treatment of insomnia. But of course, the talk is about neurophysiological aspects of sleep perception in insomnia. We did not yet see a neurophysiological difference in insomnia, no correlate of sleep perception, because the awakening thresholds were not actually different. The differences occurred in the subjective experience, in the emotions, and in the sleep perception, the tendency to say, "No, I've been awake," when they've actually were in REM sleep. So, but of course, I mean, this is of course a big step forward now relative to the older study. We have now really looked into the sleep stages themselves and shown that sleep emotions and the perception of sleep are really different in REM sleep when people are awoken from those stages. To get another step at really neurophysiological differences, we did an event-related potential study. And as you probably know, just a very quick uh, repertorium of those components. Quite generally, positive components are seen as inhibitory and negative as excitatory. The P1 is associated with arousal regulation, and it is found to be increased in sleep, and N1, negative and excitatory component, is linked to attention or environment monitoring and reduced in sleep. And the P2 function is equivocal. So we will see this in a minute. Okay. And maybe you can hear these sounds. These were guitar sounds played throughout the night. We had 50, included 50 insomnia patients and 50 good sleeper controls, again with 4 nights, and stimulation in the last 2 nights. And we did a full topographical EEG with a 10-20 system. And yeah, there were about 15,000 single tones across the night. So we had quite a good coverage of all the sleep stages, which really were also present. I should mention this, even in the insomnia patients, all sleep stages, including stage 2, 3 sleep, were really present nearly in all of the people. So there's not a very strong sleep deprivation by our stimulation. It compares about to the first night effect. The first night spent in the sleep lab creates um, um, a worse sleep, and compared to, of course, the nights spent at home, but also the second night. And our stimulation we found to be about comparable. The effect was about comparable to this first night effect. So this is the grand average ERP on the FC channel. And you see in yellow, you see the awaking, the awake potential. And you see that as we said before, the P1 component increases, the inhibitory P1 component increases here with increasing sleep depth, while the excitatory N1 component here practically disappears, especially during deeper non-REM sleep phases. There is a residual present in REM sleep. What I as yet didn't mention was that we separated using an automatic algorithm. We separated phasic and tonic REM phases, and you see a very strong effect here in the P2 between tonic and phasic REM, and exactly this fact that the P2 amplitude is very suppressed during phasic REM sleep relative to tonic REM sleep was already reported before by Salinen et al. But it's a very interesting and striking phenomenon, actually. This difference is this strong systematic difference between the two REM sleep subphases here. And now for the group difference, you see that we can observe a difference here in the P2 component. The red lines are again the insomnia group, and the black lines the good sleeper controls. But you see that this group difference here starts already during the N1, actually, in phasic REM sleep. So we observe this difference here specifically in phasic REM sleep. And since this difference already starts during N1, it can be that it is not really an amplitude difference in the P2 proper component, but that it corresponds to the mismatch negativity, which has exactly this this time range here. And then in this study, we did an independent component analysis on all of the event-related potentials in all sleep phases, in all cycles, in all single subjects. And then we rated the independent components that we found by their ability to explain the group difference. And then we had such an actually P2-like topography here for this C1 component that you see here as one cause of a difference. And then we had an actually frontal negative component here, which explained a lot of this group difference actually, and which practically explained most of the difference that we just saw before in the average here, this one. So we can confirm that this really looks like an increased mismatch negativity. You know, instead of a reduced P2, it is the addition of a negative component, which of course takes some of the amplitude away frontally of the P2. So this is the full multivariate mixed effects ANOVA table that we performed. So we took all of the sleep stages that you see here and these three components and their amplitudes, and did this multivariate ANCOVA. And important thing is here is the group difference, and then it was mixed effects ANCOVA. So we had both between subject effects and within subject effects. For example, for this subjective wake excess that I was talking about previously, how much more minutes do the subjects say they have been awake, then the polysomnogram says they had been awake, and there is a between subject effect across the subjects, and within subject effects between the nights of the same subjects, because we had 2 nights, of course, and the same for total sleep time. But the only significant difference occurred here in the P2 component that I've already shown, specifically in phasic REM sleep. What was interesting was that here this between subject effect of this wake excess was also significant. The more wake excess subjects had across groups, so across insomnia and control groups, the smaller the P2 amplitude really was. So it's in the same direction as the group difference. The insomnia group tends to have a higher wake excess, but obviously there is a group effect in this in this data, and there is also in addition to that group effect, there is another between subject effect towards smaller P2 amplitudes for larger subjective wake excess. So conclusions for the ERP study. The insomnia patients showed reduced P2 amplitude, specifically in phasic REM sleep. And this can be interpreted either as reduced P2 amplitude, and if the P2 is actually inhibitory, then this would correspond to less inhibition, or, as we found out, increased mismatch negativity. And this would say, okay, the stimuli have a larger salience to the insomnia patients during their REM sleep and phasic REM sleep. And of course, it is also interesting that it is correlates with perceived wake time across all subjects. And so it could be a trade marker of the tendency to perceive the sleep as wake. And conclusions altogether across all studies, we have found and confirmed that REM sleep is qualitatively different in insomnia. This is sometimes called instability or restlessness. Sleep staging is not complete. I said that before. Sleep staging is actually not meant to cover awaking thresholds or subjectivity or emotions. And so it's no surprise that it misses many aspects of brain state, including emotion and sleep perception. Now, our findings are important for understanding brain emotional processes and for possible therapeutic interventions. For example, use elements of nightmare protocols, and also how to address REM sleep instability and possibly REM sleep perception. So thank you for your attention, and I also thank my collaborators. Thank you very much.